Hey everyone, thanks for joining the demo for Build and Release Engineering. Myself, I am Adam, and I'm a technical trainer by passion and a Build and Release Engineer by profession. So in this demo today, we'll be mainly seeing what is Build and Release Engineering all about, or in a bigger picture, what is release engineering about? Why is it being used in companies so popular, and what are the benefits through which companies can actually do releases in a better way? So that is what we're going to focus and see the complete details about release engineering in turn. So to begin with, so for any kind of development that you want to do, generally you will be having a process through which you will be following a SDLC method, and you will be trying to do some kind of release. So what so happens in this, you begin with taking up the requirements or doing some kind of analysis, and then you proceed with coding, or you do some kind of design and then say that this is how I should approach for this problem, or this is how I should be creating my product. Then once you have completed with your coding, then you test, and once you have tested, you just go ahead with the release. But if you see how these things would happen is, you take all these things step by step, which means first you gather all the information which is required for your entire product, and once that is done, you go ahead with coding the entire project, and once you have completed with your entire coding, then you proceed with the testing. So this phase of doing step by step would actually going to be time consuming, because practically in those olden days or a couple of years back, when you are following up an age-old method of SDLC, you would take pretty much close to 6 months just for your development, and then you will take another 3 months or 4 months first for your unit testing. Then you will be doing a system testing, right? Once that has been done, then you will be doing an integration testing, and then finally you release the code. So this phase of doing testing separately, development separately, and then finally focusing on the release is going to be a time-consuming process, in which to release a product, it is going to pretty much take anywhere between 8 months to 1 year. Now, what happened in the current market? The evolution of changes is so rapid, and the market requirement is also so huge that because of the competition, you cannot literally take so much of time in delivering your product. So in that case, now a customer is coming to us and he's saying that, look, I cannot wait for 1 year. I want something to be done in 3 months. At the same point, there can be competitors for the same product or something similar who is trying to give up something better and at an earlier stage. So from the market requirement, we have to deliver things at an earlier stage. If not, we are completely going to lose the market. So in the same concept, what is that we can do? All right. So now say that I have 10 users who is working on the project completely, and they are trying to fix it and give things by 1 year. Now, if I want the things to be delivered in 3 months, what and all can I do? One practical thing what people will think is that, okay, let me try to add more resources, so that more resources you add or more people that you add to the project, you can get the things rolled on little early, or more the number of users that you add, you will be delivering it early. Now, doing this is actually going to be a problem for the cost, because each additional user that you will be adding is going to add the cost involved in the project. So because of this, the cost that you will be putting for your project will have to come down. That means you are trying to reduce your profit, what you're going to take, or the cost incurred will also be going to get higher. Now, because of that, putting up more resources will not be an ideal solution, right? So what is the next thing that you should do? Okay, now we'll say, like, let me not put more resources, but with the existing users, maybe I can ask them to stretch a little more. Maybe I'll ask them to work 3 to 4 hours every day. Even I'll ask them to work on Saturday and Sunday and get things done. Wow, that would be a brilliant idea. But definitely, you are stressing down your own people or your own employees. Because of it, what will happen? There might be a chance where the quality of your product is coming down. Now, even though you're trying to deliver it at an earlier stage wherein you're trying to give to the customer within that time what he requires you or you have committed, if the quality of what you're trying to deliver is not going to be as expected, then again, we are going to lose the market. So it is very much important that we have to think about the time, and also you have to think about the cost, and also you have to think about the quality. So these three things wherein delivering the project at an earlier stage or within a short span of time is very much required, and also whatever you try to give should be of the best quality, because only that is going to differentiate and give value to what we are delivering. But now, in terms of giving delivery quality, it is also important that you have to keep the cost that is going to be applied, or the project has to be cost effective. So these are the three major parts which is going to define how you are going to do your project as an earlier stage. Okay, so based on these three terms, people came up with modern SDLCs, which is going to help users, or which is going to help the company to roll the projects early. So in that case, it started all from a waterfall model wherein you will be doing one after the other. Now, because of all these problems what they had, they started trying to have better and better models. So in that case, modern SDLCs, like, first people started with V model, and then spiral model, and then they moved on to lean methodology, or the most widely and the popular used methodology called agile. Okay, now in that, what is that you're going to do in the agile methodology? So in agile, our agile focuses that rather than you working on a whole project as whole, wherein first you do the development, then you do the testing, it says that it breaks down your project into smaller chunks or into smaller components, so that now whatever that you're trying to do as a product, rather than that, you try to focus on each module. So that now, if I start doing my development, first I'll work on module 1, and then what else can you do? So in addition to breaking down your product, agile concept focuses on doing a iterative process of what you can do. So what do you mean by iterative? Iterative means, now since your focus is on only one module, rather than doing complete change, you go with the concept of doing the entire cycle one after the other. That means as soon as you do some changes, go ahead and do a testing and try to do a deployment or whatever you want to do to verify it. So that for each and every module that you try to focus one by one, as soon as you try to plan, you take it in terms of sprints. That's what we call it as. So each module can be achieved and you can be going on with the sprint. Because sprint is a concept wherein you will be breaking down the modules or the product into smaller tasks, and you will be doing a development in terms of incremental method. So that you will fix a time saying that for this task, this is the amount of time that I'm going to spend, and for doing this task, what and all are the important or the required subtasks for me, so that you can clearly define for doing this project, this much of amount of time is required, this much of resources are being required. Then from that you will say how much can I cover. So this will help you to achieve multiple cycles at the same point of time, rather than for focusing, or rather than doing everything one point of a time. Okay, so that is what majorly agile methodology is going to focus. So agile methodology, or is a process of SDLC wherein it combines incremental and separating your project as much as possible. That means you break up your project into smaller chunks, and at the same time you take one module and try to work on incremental method. So those is what agile is going to focus. Now again, in agile there are many ways that you can exactly implement the process. You have something called a Scrum, or you have one more called a Kanban. So it all depends on what is the method that you want to work, or what is your product's profile through which you have to adapt whatever is going to be benefited. Now, in that case, Scrum is again the widely used agile methodology, where what you do is every day you try to sync up with each and every member of the project. So we'll have something called a Scrum meeting, wherein all the members of the project will get together and they'll be sharing the information like, okay, this is the task I completed yesterday, this is the task that I have to do today, and for doing this I might need this much of time, and again for doing this task I have all the other subtasks which is a dependent task, so that you can literally break everything and find out exactly what you can do and when you can do. Suppose if you have a dependency of one task with someone else, you give the task to him and he can share it up and he can get it done at an earlier stage, so that you know that how much dependency is there, how much time is going to be required. So that's pretty much what people do in a Scrum meeting, so that you try to figure out and have a proper collaboration with the entire team. Okay. Now, in the same concept, using the modern SDLCs like Agile, how is that we are exactly going to benefit by releasing early? So in that case, release engineering is going to come into the picture. So now, what is release engineering? So if you say release engineering is a process which mainly focuses about compiling, converting the changes, or converting the compiled code of object files into binaries, where you would be doing some kind of linking, running some unit test, and also you can do deployment. So majorly release engineering is going to focus between the activities, or between the activities that happens by development and QA, and also between release management. So it is going to act between all the process, whatever happens after development, before QA can take. And also, once the QA completes, how is it going to be delivered to the customer? So it mainly handles and takes care about these two areas, wherein all those operations, all those works involved, mainly from doing a build, that is compiling your code and creating the binary out of it so that you can deliver your software system. So in that case, release engineering can be further classified into many disciplines. Because when you say that development once completes their task, QA has to pick it up, there are many tasks involved in it. What and all are there? So based on that, release engineering can be classified into sub-disciplines based on the kind of activity or what process that you have to do. In that, release engineering mainly talks about, first thing is software configuration management, which means everything that the developer is trying to code, logically he has to store it anywhere. So software configuration management is all about controlling and tracking down each and every changes that the user does or the developer does. So how will you do it? You will use some kind of tool associated with the software configuration management, which is going to help in doing a versioning. So in turn, SCM is called as versioning control or version tool, wherein you will be using some tool and you will be tracking down each and every changes what the developer, or it can be a test engineer who is modifying his test code. So any changes that you try to do in terms of a software system will be tracked using the software configuration management. And now, once the changes has been done, the developer will submit the code into the SCM tool, and after that we have to take it as a build team and do a build. So in that case, build management mainly focuses on automating the steps where the changes which has been submitted by the developer into the SCM tool will be taken and it will be compiled automatically and it will be created as an artifact. Artifact in the sense a library or a binary which you will be delivering it exactly to the customer. So that is the main focus of build management, wherein internally it will use some kind of build tools specific to the kind of programming language that you're using, so that it will automate the steps. So rather than compiling the entire project, which might contain say hundreds of files, you can use this build tool, which is going to automate the process of compilation and linking or in turn assembly of the code. So once this is done, what is that you're going to focus? All right, I have done my build, then I'll give it to the QA, and once QA does their job, they'll be coming back saying that everything is fine. Now this is the time for the release. So release management is that discipline of release engineering, which is going to mainly focus for the delivery of the artifacts or the product to the customer. So it involves mainly being the stakeholders or getting in touch with different teams or the stakeholders saying that, okay, this is the change that I'm going to give. How is that you're going to give? What is the version number that you're going to pick up? What is the platform that the user wants? Suppose, is it going to be a patch release, or is it going to be a major release or minor release or a debug release? Those kind of information is what release engineering or release management is going to mainly focus on. Okay, so it is mainly like there would be a gatekeeper who will be acting as a coordinator between the development team and the tech support team, or the team who will be responsible for talking to the customers. Okay, now talking about all those things, what happens is there is a need for an improvement in the process, because you would have tools with respect to SEM, you will have tools for doing build management, you have processes like ITIL which will define how the release management should happen. But what happens is, again, you cannot keep doing everything one after the other. So that is when continuous integration comes into the picture, where it mainly focuses saying that you do something like this. As soon as the developer tries to submit a code, or whenever he does the change and puts the file into the SEM or the repository, you immediately try to do a testing, try to do a build, and verify that the changes are fine, so that rather than waiting for the QA to pick up the entire project at end of the day and trying to do a complete testing, you can try to do a minimal testing at an earlier stage like unit testing, and verify that whatever changes the developer has done is completely okay. In case if there is a problem, don't wait until one more day to fix it. Immediately get in touch with the right group or the right person and get the things fast, so that when QA pick up a file or a binary or a product to do the test, it should be at a better stage. So continuous integration is mainly going to reduce the bad builds that is going to happen because of some issues in the code. So these are the main areas or the disciplines by which release engineering is going to help in releasing a product smoothly, and at the same time at an earlier time and with a higher quality, and on top of all these things being cost effective. Okay, so talking about this, there are many tools which is available in the market. So there may be open source tools or there may be enterprise tools. Now, depending on what is the kind of product that you have or project that you're going to work, tools might vary. And again, in the same case, there are tools for each discipline what we just saw. There are tools separately for SEM, there are tools separately for build, there are tools separately for tracking the bugs, and there are tools separately for continuous integration. Okay, so in that case, if you see, there are tools like what you just saw, seeing it here, like Git, Subversion, Perforce, Mercurial. Basically, all these things are SEM tools or version controlling tools through which the developers or the QA team will be maintaining their code, or we can control the code using that. So once the developers do the change and put the changes into these tools or into these repositories, then the build management will try to do the builds where they will use some kind of build tools to automate the build process, wherein depending on what kind of project that you're working, there will be different tools. Because if you're working on legacy products wherein it is based on C or C++, then you would be using build tools like Makefile. Suppose if you're more into the Windows side wherein you have .NET files, then you will be using Visual Studio or MS Build. And now, since the whole world is moving towards Java, you will be using the open source tools from Apache like Ant or Maven, which can help you to automate your build process completely. And now, once this much is done, As part of continuous integration, you just don't have to stop. So what can you do? Further, after you have done your build and you have verified, you can even do a deployment. Okay, so that will ensure that from end-to-end solution can be obtained. Okay, so don't just take my code, test, and basically take my code, do a build and test. You just proceed further by doing a deployment also. That can be in a production, or that can also be on your test bed, so that will ensure completely saying that whatever the changes has been done by the developer is completely fine. Okay, and in addition to it, continuous integration also focuses on few things which is latest available in the market, wherein things like doing static code analysis. So you will use certain tools like Sonar, which will help you to bring up the quality of the code that has been done by the user. So by running this tool at the end of your build, you can say that, okay, look, this is the quality of your product. You have written so many lines. Out of the so many lines, only these lines are being really used into the project, and all the other lines or the variable initialization what you have done is not going to be used. So it is better that you try to revise your code and be optimal in a better way, so that the quality of the product is going to increase. And now further, since the requirement are being increasing day by day, people are thinking more about security. So in the same ways, you use different kind of binary repositories or binary storage tools like Nexus or Artifact Managers, where you just don't have to build your tool and keep it somewhere. You can use these tools, which is called as binary repositories, where you can store and maintain the binaries or the artifacts that you are going to build. Okay, now again, all the tools can be run manually, but since we are going as a continuous integration step, we need a one-stop solution which can interrelate, or it can integrate all the steps and give, because if I have to work, first I have to use a separate server to do some kind of check-in or check-out using the version control tools. Then I have to use a separate server to run all these commands or build scripts. Then I have to go to some separate place to deploy. Then I have to go to a separate server to access the static code analysis or Nexus repository. So instead of this, you go with some kind of continuous integration tool wherein that is going to act as a one-stop solution, or this is going to act as a framework which will help you to connect between all those things. So when you are trying to do as a pipeline, you can use this as a single one-point solution tool which is going to get in touch with all the steps. So using tools like Jenkins, you define what is your build process, and for doing that process, what and all tools is required, you just use as a plugin and define the build process. So that's pretty much from the demo for build and release. And once again, thanks for attending the session today. Thank you.